In this video we're going to take a look at the sixth and final section of the Python AppSec category on Veracode Security Labs Community Edition. So the title of this lab is Key Flaws in JSON Web Tokens, and the description says JSON Web Tokens allow you more flexibility than a typical session token, but they also come with some of their own problems if not handled correctly. So we'll click Start to begin the lab. So in this section we're given an introduction to JSON Web Tokens. As in the previous videos, I'll not read these entire blocks of text. I'll just try to find bits that are really important to get the lab done or summarize some of the sections. So we have a little bit of a history here of JSON Web Tokens, and it's essentially a data structure. It's defined in an RFC, which we can take a look at, that defines a compact URL safe means for representing claims between two parties. So it can be used to replace some of the functionality usually provided by sessions and session identifiers. It provides more context than a simple single session ID can provide by embedding information or claims into the token itself rather than relying on querying backend storage for authentication or authorization details. So here's the RFC for it. I'll definitely not be reading through that, but you can do it in your own time. And how are they used? So some common uses are authentication control for APIs, server-to-server authentication, and non-sensitive state management in single-page applications. There are also some things they shouldn't be used for. For example, they're not a good replacement for sessions. Sessions often contain sensitive data about the users, and the user should not be able to view or manipulate them. This data is best left out of the eye of the user and potential attackers. And reiterated, sensitive data should never be included in the claims section of a JSON Web Token. Usually, once tokens have been generated, they'll be sent along with future requests as authorization headers. Okay, so we've got a page here that we can go and take a look at, a user API documentation. And like the previous vulnerable apps we've been looking at, it looks a little bit similar. We don't have any login functions or anything here, but we have an API which we can use to log in. In our last example, the replay attacks lab, we could register, we could log in, and we could get users. This is quite similar. It just looks like we've already got a user registered. We're only able to post to the login with our username and password, and then get users which we need to be authenticated to do. We don't need to be authenticated to do the login. And it gives an example of what an example request might look like. So we need this X session and the X signature as we had in our previous example. And unless we have admin level access, we'll only be able to retrieve our own information from the get users endpoint. Okay. Notice we also, in this one, we just had our code, we just had our terminal and code editor and stuff here, but now we actually have the web page in the lab. I'm not too sure how I feel about that. I think it should be a way to remove that, but oh well. So let's move on to the next section. In this section we'll look at how JSON Web Tokens are structured and created. So true to their name, they're built from JSON structured data, and a couple of labs ago I think we did a JSON injection lab as well, so we know about some vulnerabilities with JSON parsing and loading and things like that. And the JSON Web Tokens are broken up into three sections. We have a header, we have a claims section, and we have the signature. So the header defines the type of token and the algorithm used for computing the signature. For example, this is a header right here. We have the type, JSON Web Token. We have the algorithm, is HS256. And we have the claims section, which contains RFC defined details. Let's see if we can have a quick look at that. So we have claims here, and there are some examples of claims that exist. So we have this subclaim, for example, which is the subject, audience, expiration time. Okay. So in this example here, we have the sub, we have the expiration, and then we can also have custom claims in here as well. And then finally, we have the signature of the token. So if we take a look at this example claim section here, sub and expiration, we just had a look at those defined in the RFC, and it says test is a custom claim, but I think it means username. Maybe this just hasn't been updated. And the JSON structure to then URL safe base64 encoded and concatenated with a period, so there'll be a dot in between each base64 encoded segment, the first being the header, the second being the claims, and the third being the signature. So how the signature is generated depends on the algorithm in the header. There are several different methods, more than can be listed here. The ones that are going to be covered here are HMAC and RSA sign-in. So the signature and the other two sections are again joined with this period. When a JSON Web Token is verified, the token is split on the periods, breaking it into the three different sections, the header, the claim, and the signature. The header and the claim is then reversed back to their JSON state, so they can be easily back to their human readable state. And the signature is regenerated from this data and checked for a match. Some other things to bear in mind is that the algorithm is used for generating the signature only. It doesn't protect the claim data, and all the claim data can be easily decoded in a normal JSON Web Token. Secondly, the header can always be decoded, so the algorithm being used isn't secret. It's publicly available. So to complete this stage, we're asked to make a GET request to the token endpoint to get a sample token, then use the JSON Web Token.io service to decode it and check the signature with the secret and view the claim information. Okay, so let's go and try that now. We need to make the GET request first of all, so that means we can just go here. The easiest way for us to do that is just going to be to go to token. We can grab this token right here. You can see that we have base64 URL safe strings. We've got one, we've got a period, then we've got two, period, and three. Okay, there's a dash in between that, but that's the three. So we have our header, our claims, and the signature as well. Okay, so let's take this to be decoded. We throw this in here. We get back our user1 and admin. That's weird. Okay, there we go. User1 and the level is admin, but we get here invalid signature. So we were told that the signature was secret with threes instead of. Okay, apparently it just let me type in S there and it says the signature is verified. Does that mean? Not too edit the payload and secret. Okay, well, I mean, it seemed to just verify that. Let me try a different service. JWT decode. Easily validate them here. Let's paste this in here as well. Alright, invalid, token signature has failed. Okay. Well, it's just showing that the signature's failed anyway. What if I now put in secret there? Invalid token signature has failed. Check the signature with the secret. Okay, well, we've put the secret in there. Let me just double check that. Grab this again. Yeah, not too sure what that's about actually. Oh well. Let's see what else it's asking us to do here. Decode it, check the signature. Well, we've decoded it. The signature is verified here, but it also verified on just typing in the letter S. So I'm not too sure about that. If somebody knows more about what's going on there, they can let me know in the comments. Let's move on to the next section. So in this section we'll be finding out how to use the users API. It says here, before describing and exploiting the vulnerabilities, we're going to talk about how to use this API. So we have the documentation there, which we've already taken a look at. Let's open that again. And it has the login endpoint and the users endpoint, which we know, so we can send off a post request to log in, and then we can do this get request as well. We're being told that a user's already been set up for us, so we don't need to worry about creating our own. We've got a user here, user1 with test1234 as a password, or we can do user2 as well. And it's telling us to send this post request to this endpoint. So let me just copy that. I'm going to paste it in here, We send that and we get back our token, JSON Web Token. Once we've done that, then we can make the request for the users and put in that token as the XAuth token header. Okay, that's interesting because if you look here, it actually says that an example request might look like this. It doesn't. It has X session and X signature. Maybe that's just been taken from the previous lab and not updated. Okay, so we could do that in here. What I'm going to do actually is I'm going to open up the replay script that we used last time, and I'm going to go and make some slight changes to it. Let's put in this new URL. We've got a user1, and we had the password test1234. We'll leave the origin header the same. The signature, let's take out the get signature stuff. Let's take out register. We don't need to register. So we're going to log in, send in those login creds, send in that origin header. I don't think there's anything else needed for that. Doesn't look like it. Okay, and that's going to get us back this message, and in the message we have the token, so we want to extract that. So it's basically going to be the same as we've done here, but instead of grabbing a secret and a session, we're going to grab a token, and then let's try and just print out the token. And see what happens. Okay, so we'll do Python replay. Yep, we send that off. We get back our token, our message with our token in it, and here's our token printed out for us right here. So we can take a copy of this token. We can go to, let's go to one of those decode things then, JWT.io. Although we could just do this probably in Python as well. I'm not 100% sure what the function is to do it, so it'll just be easier to jump here. But we can see here we've got our claims, we've got username, user1, and level user. Okay, cool. Let's go back and see. So now what we wanted to do was actually make the request to the users API with this XAuth token. So to do that, we'll go back to our Python script. I'm going to stop printing this, you don't actually need to print that. And now we'll say headers XAuth token is equal to our token, and then we want to make a GET request this time to the users API. And let's then just have a look at the response as well. We'll load the response, we'll print it out. And we'll try and run that again. We'll see that we've got no method called gets because we made a typo. Let's do that again. And there we go. So we get our token, we send off a new request with our token, and then we get back our user1 at test.com with our bcrypted password. Comes back with our token as well. Okay, cool. Is it asking us to do anything else? Doesn't look like it. Now that we know how to use the API, let's see how we can abuse the JSON Web Token and try to bypass it to elevate our privileges. So in this section we'll be looking at the first flaw, which is how we can bypass correct validation by changing the algorithm to none. So it says the remainder of this lesson will guide us through two different vulnerabilities that were found in the JSON Web Token specification that, without knowledge of how to avoid them, could allow attackers to bypass the control completely or inject their own information into the claims. So this first vulnerability is going to be with the alg setting. So we know that the header, I can't see any examples here, right here, the header had the algorithm and we had it set to HS256, I think. But what it says here is that although we can use the HMAC and the RSA signature generation methods, it also includes this interesting value of none. So we can actually disable the algorithm altogether. And it says it was designed to allow creation of completely trusted tokens that don't require signature validation, but in practice it essentially means that regardless what the signature is, there is no reason to validate it. So this is obviously a major problem because the algorithm's publicly available. It's easy to decode the token and see what it's set to, and then very easy for the attacker to change it and bypass the security. So we're going to test this out. It says we can perform this exploit against our example users API. We're going to make a login request first of all to the URL which we've already got in our code. This should log us in. It'll return the message with the token, and then we can take that and decode it and find that the algorithm is set to HS256, meaning it'll use the HMAC hashing for signature, and we're going to try and change that to none. So you can see here how this is going to be done. We're importing base64 into Python, and then we're base64 encoding the header and then the claims, and then it's saying that we're just going to send that without a signature at the end. So we're just going to have the dot and then nothing at the end of that. So since we're changing the algorithm the system will use to verify the signature, it also doesn't matter if it exists or not. So because we're setting this to none right here, it doesn't actually matter if the signature exists at all at the end. And it wants us to make a request to the user's endpoint with this token. So let's grab this first of all. Take this to our code, and we'll grab the token anyway, but we're actually going to, let's go back here. So we're going to want to append these together. Let's go back to our code. We'll say the auth token is actually going to be equal to header plus dot plus payload, and then we don't need the signature. And let's try and run through that and see what happens. Can't concatenate strings to bytes, so we could convert this to string, but if we do that it's going to have the little b in front of it. So actually we'll want to decode, and you could do UTF-8 or something there. Hopefully it'll just allow us to just decode and that'll be fine. Try that again. Sends that off, it comes back, and notice that it's returned the details for both users. So if you go back here and look at the lab notes, it says since the level in the values token claims to be admin, so you see right here we've claimed the level to be admin of user 1. You'll get both the listing of both users, not just our own information. So how does this work? Well, it works because the functionality that's being used to parse the incoming token has implemented all of the algorithms, including this none, so the developers allowed that to be permitted as an algorithm. And secondly, it's blindly using the algorithm defined in the token, assuming that it's the one that's intended to use without doing any secondary verification. So it actually says here, whenever this was first brought to the public's eye, there's a report here. Several of the more widely used libraries implemented a secondary check that compares the algorithms on the incoming token against the one desired. It can then fail immediately if those don't match, preventing any further bypass. If you find yourself working on JSON Web Token functionality or making a package of your own, it would be in your best interest to include this kind of secondary check, and also potentially disabling the non-algorithm altogether. And it says that later on we'll be looking at how we can correct this issue and make use of an up-to-date package to replace our custom logic, which is introduced in this vulnerability. So let's move on to the next section. So in the previous example we looked at changing the algorithm to none to bypass any signature validation, but there are other problems that can come from this root cause as well. So in this example, in these labs, we're looking at HMAC and the RSA algorithms, and HMAC uses a single secret value as the key, along with data from the header and claims to create the signature, whereas the RSA algorithm works in a similar way but uses public and private keys to handle verification and generation respectively. So typically private keys are used to decrypt and also to sign, whereas public keys are used for somebody else to encrypt data or to verify data that's been encrypted with the private key or it's been signed with a private key, should I say, sorry. So public keys, as the name suggests, are public. They're not hard to come by, and this is a major part of the problem. So in this example, we're going to generate a JSON Web Token using the RSA method with some predefined keys. It says we're going to use a PyCrypto package for signature generation and verification. So let's swap over to, it's actually asking us to update some of the code here. So let's go to the code editor. We've got JSON Web Token custom.py, and it wants us just to change this algorithm to RS256 instead of HS256. You can see we've got a HMAC secret here. So we'll save that. And then it asks us to make the same login request as we would do to, so make the same request to login and users as a normal user would, and see what the token looks like. It's saying it'll be different length. So let's go back and run this again. If we try and run that now, we're not going to set our tokens here. Let's comment this out, and we're going to set our token to equal. I didn't mean to delete that, just in case we need it again. Just comment that out separately, and we'll just set it to equal the token that we've captured there. So we save that. Let's go ahead and run the replay. And we get an error here that the string indices must be integers. Let's go back and change this to, let's print out response JSON, see what's going on. And we're getting internal server error whenever we try to run that. Let's go back and refresh this page. It's still loading okay. Can we go and get a token? We can get a token okay. Has the token updated? So it doesn't show RSA there, notice. Okay. If we go back here, let's save and run. Let's try that again. Nope. But it's saying that we should be able to just retrieve those. Okay. If we go to our logs here, we see it's trying to open the secret keys username, and it's not finding keys user1 private.pem. Let's go to our code here. The JWT custom. So you can see before it was just setting this secret to equal our secret right up here, whereas now it's trying to set it to this private.pem with RSA, and we don't have a private.pem, and then it's using public.pem here, so it needs this keys folder. We don't have keys. Can I get a tree here? Get a tree and see if we can see any keys in here. No. Alright, so it looks like actually the challenge, it looks to me like the challenge is broken. Alright, let's see what it's asking us to do here anyway. So what we wanted to do was get back this token and then change the algorithm value. So if we changed it from RSA to 256, an interesting thing would happen with the token processing. So before it was using the public and the private key to verify the string cryptographically, and whenever we switch that over to HMAC, the public key now becomes a secret that's used because there's only one value instead of two. So that means that we can just get the public key and we can generate our own tokens. So they've actually given us a script to build a token here. So maybe we will be able to test this out with that. Maybe it's not too much of an issue, although I think it's still going to run into those errors. Let's see. So rather than trying to walk through all the steps needed, the script has been provided for you. It reads in the user's public key, it uses it as a secret for the HMAC, and then updates admin claim. Okay, let's have a look at this first of all. We've got whereabouts is it? Forge token. Okay, so forge token looks kind of similar to the last one. They have this base 64 encoded, and they're just manually putting that together. But they're putting it together as HS256. We're obviously using the RSA. So let's see what happens here if we run this. We'll do Python 3 forge token, and then we can now, if you make the request to the user's endpoint with this token, then you should receive all of the data, not just your own. Okay, let's take a copy of this then. Let's go back, and we're not able to do the login, which I imagine is going to cause problems, but let's try and set the token to equal this value. And I'm going to take out this login then. We'll go straight to the users. Did the users, it was users get, but it didn't take in data, did it? Let me go back. This was the get for the users, and no, it didn't take in the data, it just took the auth token. Alright, so let's go back. We'll take out the login creds from this section, and let's try that. We get internal server error. Okay, so it looks to me like, presumably, yeah, we go back to our logs here, it's not able to find public.pem. So there seems to be an issue with the lab. Okay, well, I'm not going to have time to make this video again because I'm just going through these labs and kind of making some quick videos in preparation for the hacker games that they're running next week. But I will contact them to let them know that the lab appears to be broken. I mean, really, we could probably go and just generate these keys anyway, but again, I don't really have time. As long as we understand what's happening with the vulnerability and how to fix it, I guess that's the main thing. So in this case, that token would have given us access to all of the users, not just our own. We did update this, but we weren't able to actually verify. So how do we fix these vulnerabilities? So we've looked at two examples, and there are two main changes we could make to fix those two vulnerabilities. The first is to prevent the use of the non-algorithm, which we saw being used in the first example, and the second is to ensure that the algorithm used for parsing and decoding the token is what's expected. So the first change, relatively simple, in the JWT custom file that we have here. Oh wait, that's the forged token file, JWT custom. So we could remove these lines where, let's see where we have that, if JSON header, here we go, if the JSON header algorithm dot lower is equal to none, it's still returning the JSON payload, so we can just take that out. And let's take that out now, and updating the if check below to if RSA256 would mean that if the algorithm value wouldn't match either HS256 or RS256, then the validation would fail. So, and then they want us to change this elif to an if statement. So if it's HS256, we're going to do this, else if it's RS256, we'll do this, and then we'll only do this if it was the RS256. Or the HS256 is going to do some more stuff there. So it has to be one of those two algorithms. So make this change, try the non-attack again and see if it works. So we can save this, but I mean, let me try and run this again. Internal server error. So we're going to need to go and change this back to use the HMAC instead of RSA. Now if I run that again, invalid credentials because we went and made all different changes here. Let's set that back to, this was the blank attack. Okay, this was the blank attack here. Let's try that again. Invalid credentials provided. Interesting. Let me go and double check the credentials again. Go previous user 1 and test 1 2 3 4. Yeah, it's definitely correct. Let me try just one more time. I'll boot this again. So it's just given the same URL. Yeah, invalid credentials. I don't know, something wrong with the lab. But I mean, I guess that would have fixed it anyway. We can't test it, but that should have fixed it. They also suggest that we could use third-party libraries, so give some libraries that we can pick here, and they said that they opted for the Python JWT library, PyJWT. So I was saying earlier that it would probably be easy enough to decode it and stuff in Python. I just wasn't too sure of the library and just did it online because it would be quicker. But as they say, you can also check out jwt.io and have a look at the different libraries that they'll suggest for it. Okay, let's move on to the next section. So in this final section, we're being shown how to actually use this library. So let's run pip install PyJWT, and you can see that it's already installed in this case. If it's not already installed, we can go through download the process. Now we can move on to the code. So let's go to this JWT lib, and this code makes use of the PyJWT library. You see here JWT algorithms. It's still trying to use keys that aren't going to exist though. That's the only problem. They mention here that the code's a lot shorter, leaving room for less potential bugs, and the generate and parse functions are the same, but there's one big change that helps prevent from issues before. The algorithm to use is hard coded in the use algorithm. So using the new code, there's one slight change to make to our application so we can use this new code. Before, the code was importing JWT custom as the user manager. So let's go to the app.py, and right here we have import JWT custom. Instead we're going to say import JWT lib as JWT manager. We save that, and then here it's just describing how using this hard-coded value prevents both the RSA to HMAC switching vulnerability and the use of none at the end of the call to JWT.decode. Inside of parse, there's another control added, the use of the algorithms parameter, and this is being populated with the only allowed algorithm, locking it down regardless of what the header says. It then tells us that we can try it out our 2 attacks again against this, but presumably we actually can't. Yeah. Okay, well that's this lab completed. So there's some general tips here about using third-party code safely, some more resources on JSON Web Tokens, and here's an article here. Let's take a quick look at that. I'll throw some of these links into the description as well. And it looks like there's a good article here with plenty of diagrams showing exactly how the JSON Web Tokens work, probably some good information about the vulnerabilities as well. Anyway, I hope you've enjoyed this video and this video series. Again, I'm kind of just going through this stuff, getting ready for the Hacker Games, which will be beginning. Let me open this up, do a bit of promo for them. Although showing the Broken Labs probably isn't great promo. So this Hacker Games is on 15th to 26th of March 2021. Presumably they'll be doing something like this next year as well, and it's going to provide different universities are going to be competing on this with, I guess, labs that aren't just in the free community labs, but these labs are free to sign up for, so go and check them out.